Hello, this is Mr. Precella. We're working on the review sheet for the first in-class college algebra test today. And I'm going to just be starting at number 1, working straight through it. We've done a lot of stuff this semester so far. We've started off simplifying square roots, working with imaginary and complex numbers, and we solved quadratic equations, factoring, square root method, quadratic formula. Now I'm just scaring you. Let's just go ahead and jump right in and get started. So problem number 1 says write this number as a product of a real number and I. So if you look at the answer choices, you can tell, okay, there's going to be an I somewhere in your answer. Remember I, those are the imaginary numbers. And we have the square root of negative 275. Well, to simplify that right off, because you have the square root of a negative, that means you're going to have an imaginary number. And so I'm going to go ahead and write the little pink I right there somewhere. And then I need to simplify that square root of 275. Well, if you have one of those calculators where you can just punch it in, the square root of 275, and it actually reduces it rather than gives you a decimal number, then great. I have one of those up here with me, but I'm going to act like I don't. But I am going to take advantage of the multiple choice options. You may as well take advantage of the fact that it's multiple choice, because you have the disadvantage. The disadvantage of multiple choice is it's right or it's wrong. So you may as well take advantage of the fact all of the answers have an 11 in it. So let's see, what's 275 divided by 11? We'll punch it in here. 275, you might not be able to see it. And, 275 divided by 11 is amazingly 25. You can see that now. So we could rewrite that 275 as 25 times 11. And now just simplify from there. Let's see. That blue square root of 25 would be 5. And we normally put the I in front of the square root. So 5I square root of 11. And that's how the answer choices are. Let's see. Oh, is it answer choice A? Look really closely. Answer choice B, that I is under the square root. Okay? So answer choice A. Write your answer in the blank. That's what I'll be grading. Okay. Now, problem number 2 says write this number in standard form. You might remember some homework problems just like this. Let's see. 6 minus the square root of negative 108. Okay, 6 minus the square root, I'm going to go ahead and give a hint by putting that negative in pink, 108 all over 2. Well, I'll start off by simplifying under the square root symbol. Okay. And do we have an I? Well, yeah, we have the square root of a negative number. So there's going to be that pink I here. Now, if you have one of those calculators like this one, where you can just, let's see, how can I write? There. Let me clear this. On this calculator, if I punch in square root, if I go negative 108, it's going to give me an error, as it doesn't work with imaginary numbers. Now if I punch in just square root 108, it goes ahead and simplifies it for me. 6 square root of 3. That's a nice little calculator to have. Some of those pink ones out there do it. But if you don't have that, well, looking at the answer choices, there's 6's and 3's, so that sort of gives you a hint. 108 divided by 6 doesn't give us a perfect square. Oh, it's an 18. Oh gosh. You know what? Maybe I should do it with but 108 divided by 3. 36 times 3. So you can sort of use the answer choices to help you simplify these things. I could think of this as 36 times 3, which would reduce down to just a blue 6. Hard to tell the colors up there on the projector. And then a I and a square root of 3. So the first thing I do is simplify that square root. And I'll just write it with the black so it's easier to read. 6 minus 6i square root of 3 all over 2. Well, there's a couple of ways you can simplify this. Either way, you're going to get the same answer. You can separate it like that, or you can look at the 3 numbers that aren't under the square root and say, what can I divide both of those? All 3 of those by? Well, you can divide them all by 2. So it doesn't matter if you separate. 6 over 2 is 3. Then minus 6 over 2 is 3. Or you could just say 6 divided by 2, 6 divided by 2, 2 divided by 2 is 1. Okay? Either way, you're getting 3 minus 3i square root of 3. See, which choice is that? Is that option C? Okay. Now let's do problem number 3. Y'all caught up with me? Are there any questions? Problem 3. It looks like it says find the sum or difference. It's actually a difference. Why difference? Well, we're subtracting. 8 minus 7i minus 2 plus 4i minus 2 plus 9i. Well, to subtract complex numbers, you've got to distribute that minus in front. Oh, let me lift this up some. Okay. Distribute the minus in front of the parentheses, and then combine the like terms. Okay. So the first set of parentheses we don't really need. That 8 minus 7i is just there to say there's a complex number. So I'll write it without any parentheses. It'd be 8 minus 7i. Then distributing this minus. That's going to make it a minus 2 into minus 4i. And then what? Another minus 2. And is that a minus 9i? So distributing that minus just changes the sign in front of the numbers in the parentheses. So combine the like terms. Let's see. We have 8 minus 2 and minus 2. 8 minus 2 minus 2. Is that going to be a 4? Yeah, you knew that way before you ever knew what algebra was. Now let's combine the I terms. Negative 7 minus 4 minus 9. I'm going to add negative 7 plus a negative 4 is negative 11. plus a negative 9. That's a negative 20i. So we have 4 minus 20i. That's another C, isn't it? Any questions here? Just working through the review sheet. Problem number 4. Let's see what that is. Problem 4. Oh, let me see. Do I need to focus? Focused, okay. Everyone loves that in the video when it blurs and stuff. Okay, 7 minus 2i times 5 plus 7i. 7 minus 2i times 5 plus 7i. Well, here we're multiplying complex numbers. If someone asked you, how the heck do you do that problem? What do you do? Well, I guess the easiest way to say you're going to FOIL it out. And then there's something about the I squared. Do y'all remember? What am I going to replace the I squared with? Negative 1. So if someone asks, how do you do number 4? How do you multiply complex numbers? Well, you FOIL it out and then replace the I squared with negative 1 before combining the like terms. So let me FOIL this out. I would have 35 plus 49i minus 10i. And what's this last one going to be? Negative times positive is a negative 14. I times I is I squared. So be careful. Now, before you start combining anything, if you replaced this I squared with a negative 1, negative 14 times negative 1, that's going to be a positive 14. All the I squared does is change the sign of the number in front of the I square. Okay? So we just have a, can y'all see that orange? I made that a plus. Okay. The I square is gone. I'll replace it with a negative 1, so that made this a plus 14. Now let's combine the like terms. Let's see, we have a 35. What am I going to combine it with? 14. Yeah, 35 plus 14. That'll be a 49. Then 49i minus 10i. Is that going to be a 39i? But be careful, you can't combine the 49 and the 39. Just leave it like that. 49 plus 39i. And gotta look at these very closely. I'm thinking that is C, isn't it? Okay. This review sheet is posted under document sharing if you want your own copy of it. Okay. Any questions? I think that's it on here for complex numbers. So you might notice there weren't any division. There was none of that. Do you remember the division? You multiply above and below by the conjugate of the denominator. Now that doesn't make it onto this test. It might be on the at-home quiz. There might be one of those, but I don't remember. So, and I shouldn't mention that because not every class has online quizzes. But y'all's does this semester. As we're making this video. If you're watching this video sometime down the road, ignore my statement about online quizzes if you don't have any online quizzes. So, number 5. Starting with number 5, we're beginning to solve quadratic equations. I'm going to do a physical zoom in and refocus. Maybe get it a little bit larger. Refocus. Okay, problem 5. It says solve the equation by the square root property. Okay, here's number 5. It says x squared equals negative 169. With the square root property, you're just going to get the x by itself, and you do that by taking square roots. Basically, over here on the left, you drop the square, and on the right, you take the positive and negative square root. So on the left, you're just dropping the square, say x equals, and on the right, you say plus minus square root of negative 169. And we have this black plus minus here. What's the square root of negative 169? Well, the square root of 169 is a 13. 13 times 13 is 169. You might want to punch that into your calculator if you aren't sure. But I'm not going to just stop there. Why? Yeah, there's a negative under that square root. There should be an I in your answer. So plus minus 13i. Let's see. Is that C? Oh, wow. If in doubt, guess C. It looks like every answer is a C. So, well, no. The past 4 answers have been C. And I'm joking about the guessing, okay? These are really random. Okay, so don't start thinking, oh, well, there's always C's, more C's than anything else. No, there isn't. Looks like number 6 is the same type of problem, except maybe the instructions are worded differently. It says use the square root property to solve the equation. So problem number 6. We have x squared equals 18. You can sort of tell just by looking at the answer choices that will there be an I in this answer or not? No, okay. So drop the square on the left. Take the positive and negative square root of the number on the right. And this problem is probably a little bit trickier than it really should be, as you might be tempted to choose answer A, but no, don't choose answer A. Why? Because I think we can simplify square root of 18. If you have one of those calculators that'll let you just punch it in, or this is one that you can do without too much effort. Think of it as 9 times 2. The square root of 9 is 3. Square root of 2. So plus minus 3 square root of 2. That is D. Are there any questions? I seem to be doing this faster than I was planning, or going through it faster than I thought I would. No questions. Number 7 is another one that says use the square root property. And at first glance, you might think, well, wait a minute, this one doesn't look like the other two. The other two were just x squared. But you might remember having some homework, like this one, number 7. You can still do that square root property. Why? Well, you can still drop the square on the left, take the positive and negative square root of the number on the right. So this one's made for the square root property. Let me write it down. 2x plus 3 squared equals 10. So I'll drop the square on the left and take the positive and negative square root of the number on the right. That's what I was doing over here. That is the square root property. Drop that square root, take the positive, negative. What you're doing is taking square roots of both sides, so it cancels out that square there. Well, the only difference between this one and problems 5 and 6 is x isn't by itself now. So let's move the stuff around and get the x by itself. Well, I would move the 3 over. So we have what, a negative 3 plus or minus square root of 10. Oh, my pretty blue pen is dead. Okay, I'll chunk that one. And just go to the other blue. So I'm moving the 3 over. I'm trying to get the x by itself. Now, only thing left to do is divide by 2. Would that get the x completely by itself? Oh, wow, this is messy. So we have negative 3 plus minus square root of 10 over 2. Let's look at it closely. These answer choices all look alike. Like B, C, D at first glance look the same. Which one is it? It is C, isn't it? What's the difference between B and C? Well, B has a little I there. You've got to look at these very carefully. Okay? So back to C on that one. Okay? And next. Any questions? Looks like we're about to start some quadratic formula problems. Problems 8 and 9. It says solve the equation using the quadratic formula. Let me write it down. And since it says specifically use the quadratic formula, that means it's not going to factor. So you're not going to need to try to do some factoring or something. Let's see. Well, in order to use the quadratic formula, it has to be written in that standard form, ax squared plus bx plus c equals 0, and there shouldn't be any fractions. So we had some problems like this, where you had to cross-cancel out the denominators. What do you think? Do y'all remember, what would I multiply straight through by that would cancel out both the x and the x squared? Do you remember what it would be? The one with the bigger exponent, x squared. If you multiplied straight through, every term has to be multiplied by x squared, even this number here that doesn't have a fraction on it. So I'm going to multiply straight through by x squared. You might want to write it as x squared over 1 so that you can see the cross canceling. Like right here, what do we have? I'll write it first with just the colors. We have the blue 2 and the green x squared equals, I can cancel this blue x, it looks black up there on the screen, but it's blue, with one of these green x's. Okay, so I'll mark that one out, and I'm going to mark out this exponent here. Okay, that's just my way of saying I'm canceling one of those x's. So I have the blue negative 10 and the green x. Now, this minus right here is that one. And on this one, the x squares cross cancel. All that's left there is just a 5. Well, we have that minus and the 5. So at least there's no fraction. Let's get it written in standard form. In order to use the quadratic formula or to use factoring, you got to have it in that form: ax squared plus bx plus c equals 0. So I'll just move these things over. I'm not moving the 2x squared over because I always like that x squared term to be positive. I think it's easier regardless of the method if that first number's positive. That's why I'm moving these over. So here it is written in one color. 2x squared plus 10x plus 5 equals 0. Now it's in the form ax squared plus bx plus c equals 0. So a is 2, b is 10, c is 5. I'll go ahead and write out the quadratic formula, and then I'm going to plug in there. What's the quadratic formula? Negative b plus minus the square root of b squared minus 4ac all over 2a. So plugging in there. When we were doing the homework, I suggested write the formula down every time you use it till you have it memorized. Negative b, well, b is 10, so we have negative 10 plus minus the square root. This quadratic formula is one of those things that it's really best not to show too many steps. If it's something you can do in your head or easily with a calculator, do it rather than showing a different step. Now the b squared, I think we can do that either in our head or if you need a calculator, 10 times 10, it's 100. I'm just going to write 100 rather than 10 squared. Then minus 4 times a times c. So 4 times a is 2, c is 5, all over 2 times a. 2 times 2 is 4. I do the bottom stuff in my head also, the 2a. 2 times 2, 4. Now let's simplify under square root. There's my calculator. Let's see. Okay. I'm using my phone calculator just because it shows. 100 minus 4 times 2 times 5. 4 times 2 is 8 times 5, 40. 100 minus 40 is going to be 60. So, I meant to circle the square root here. For some reason I circled all of that. It's the square root I'm simplifying. So we have square root of 60. There's no phone calculator of mine. If I go square root of 60, it gives decimal number. Okay. Over here, this little Casio. If I punch in square root of 60, You can't see it. It gives 2 square root of 15. It simplifies it for you. If you don't have a calculator like that, that's okay. Look at the answer choices. Odds are 3 to 1 that there's going to be a 15 under that square root symbol, right? So if you punch in, okay, what's 60 divided by 15 in your calculator? That's a 4. So you could think of this 60 as 4 times 15, which would reduce, oh, sorry about that. 4 times 15, I'm still simplifying that square root of 60, which would reduce to 2 square root of 15. Y'all see how I simplified that square root of 60 by hand? What perfect square divides into 60? Well, 4 times 15. You have a feeling there should be a 15 in there somewhere just because the answer choices. 3 of the answer choices have a 15 in them. So odds are 3 to 1 that there'll be a 15. Now let's write it all as one big fraction, replacing the square root with 2 square root of 15. It'd be a negative 10 plus minus 2 square root of 15 all over 4. You might be thinking, oh wait, he messed up. That's not one of the answer choices. No, I didn't mess up. It's not finished. I can reduce that. So the way I'll reduce is what number divides evenly into all 3 of these numbers that aren't under square roots. Don't look at the 15. A 2, if I divide all of those by 2, I'd have a negative 5 plus or minus square root of 15 all over 4 divided by 2 is 2. Okay. So negative, oh, I was about to say A, but no, it isn't A, is it? It is it D? You've got to look closely at these. Right? Any questions? Hopefully you're thinking to yourself, oh, well, this stuff seems to be similar to homework, except homework mostly wasn't multiple choice. There were certainly, if you've done the homework, and hopefully you have. Why? Well, it's part of the 25% of your course grade. So hopefully you've been doing the homework. So number 9, right off, it looks to me like it's a little bit easier than number 8. It's another quadratic formula problem, but there's no fractions in number 9, unlike number 8. There is something we need to do to get it written in standard form. We need to move the 10 in and the 2 over by adding. So we'd have 4n squared, then a plus 10n and a plus 2 equals 0. Okay, so there it is in standard form. I'll write out the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. You need to have that memorized at least for a few minutes on test day so you can write it down on your test or on your scratch paper or somewhere. Okay? Hopefully you'll have it memorized for longer than just a few minutes. But you know what I didn't do? I didn't write out A equals B equals C equals. Let's go ahead and do that. Here A is the positive 4, B is 10, C is 2. This is seeming very similar to the other problem. It's not, is it? Number 8. Where that one is. Oh no. On the previous one, A was 2, B was 10, C was 5. Okay. So it is similar, but not the exact same. So plugging in negative B. So replace the B with 10. Plus minus the square root of B squared. Well, 10 times 10 is 100. Minus 4 times A times C. So 4 times A is 4 times C. All over 2 times A. 2 times A, I'm going to go ahead and do that in my head. The 2A, the 2 times 4, I'll just write an 8 down here. Now, y'all caught up with me? What am I about to do next? Simplify into that square root. So let's see. 4 times 4 is 16, times 2 is 32. If you punch in 100 minus 4 times 2, you're going to get a 68. So rather than tormenting you by trying to show my calculator there, I'll just do it for you. And notice there is no 68 appearing in the answer choices. Odds are 3 to 1 that there should be a 17, right? So 33 certainly doesn't divide into 68. But what about 17? What's 68 divided by 17? 68 divided by 17. Is that a perfect square? Yes, a 4. So I'm going to simplify the square root of 68 by writing it as 4 times 17, which will reduce to 2 square root of 17. Okay. So can y'all see that? Any questions? How I got that reduced to 2 square root of 17? Or if you have one of those little Casio calculators that I like so much, but I can't really show it to y'all up here. Square root of 68 equals 2 square root of 17. That's a nice little feature. It saves you a little bit of number crunching. Okay. So now, write it all as one big fraction, replacing that big circled square root with 2 square root of 17. We'd have negative 10 plus minus 2 square root of 17 all over 8. And can I reduce that some? What could I divide all 3 of these numbers by? A 2? Okay. So let's divide all 3 of these numbers by 2. We'd have a negative 5 plus minus, or just a 1, so I'll just say square root of 17, all over, what should be in the bottom? 4? let's see, which one is that? That is, I'm thinking it's answer choice A, isn't it? Okay. -5 plus minus square root of 17 all over 4. Okay. I need to think I've done enough here. So I think I'll stop right now on this review sheet, and we'll continue working on it later this week. Okay, so thank you very much for watching or listening to this, and I'll be continuing this review sheet another day. Okay, thanks, bye-bye.